Hello, everybody. It's Dr. Dave with Physics 150. We had a lot of questions about the drop lab and a lot of different experiences in the classroom, and we wanted to clarify that. So I'm making this video to try to help you understand what it is we're after. And I must apologize in advance. I'm at home. I have 3 children. It is a very animated day in my home, so you're going to hear a lot of background noise. Hopefully you can still understand what's going on here. Okay, so what do we want from you? I've tried to list out everything I think we want from you, right? So we want a description of your procedure. How did you get the data that you're presenting? We want your data presented at a nice table that we can see and understand what it is. We want an estimate of your reaction time. In part A, we want 3 plots of your data. In part B, we want at least 2 plots of your data, meaning that you may not need 3 depending on the object and how you took your data. We also want units. If a number has a unit, then it should appear with its unit in the write-up. We also want you to be mindful of significant figures. We're not going to nitpick you if you've got 1 extra significant figure, maybe 2 extra figures, but beyond that, we're going to have to pay attention. Anytime you have an axis, please put a label. We also want you to have error bars. I'm going to talk to you a little bit about how to do that in this video as well. We also want to see a calculation of the acceleration for each object and details of how you did it. Numbers that appear within this write-up without support or explanation will result in a loss of points. So several students have said to me, "Hey, Dr. Dave, I calculated the acceleration of gravity to be 18 meters per second squared. Am I going to lose points?" And the answer is no, you're not going to lose points for a wrong value alone, right? If you've done all your work correctly and your experimental procedure shows that it's 18 meters per second squared, I'm not going to mark you off for that. Is that the correct value? Absolutely not. Does that mean that you took your data wrong? No. It simply means that the limits and what we were doing did not support a better measurement. However, if your number is totally nonsense and the work to get there was nonsense, then yes, you will lose points. So if you've done your work correctly in this lab and you get an answer that's not physical, it's not realistic, you won't lose credit for that. That's what your data shows. All right, so what are these plots that we want? So let's say you've collected your data. And let's remember we want our independent variable on this axis and our dependent variable on this axis. So if I make a plot of my data and I say, okay, here we go. What's the acceleration? Well, from this, it's you can see there's some kind of a curve that goes through that data. I mean, maybe it's a line and it's just not great data, but it looks like some kind of curve that goes through that data. But how do I use that curve? Right? That's really the central question, is how do I use this curved data to produce a number? That's really the goal of this lab, is how do I use this data to support a number? And so your goal is to somehow take this data and plot it so it really looks like a line. And that's what I'm going to talk about how to do now. So when we say we want 3 plots, the first is just your data, right? You determined this number, you measured that number, make a plot. Then your goal is to make another plot using this as input data that's linear. What's your third plot? Well, once you have determined, or you've set your y, you've measured your t, for each of your data values, you could calculate an acceleration value. And when you make that plot, it'll probably look something like this, which is really hard to interpret. So what we're saying here is the following. In real life, when you're doing a real experiment and you're taking real data, you have no idea what you're going to do with it. That's the approach we're taking now. So you're going to take that data, you're going to make a plot, and if it doesn't look good, make another one. And if that doesn't look good, make another one. You keep making plots until you make sense of your data. And sometimes the conclusion is, my data doesn't make any sense. But that's the actual scientific process, and that's what we're after. Okay, so why do I want to make things linear? The why is actually really simple. There are many equations of curves, but there's only one equation for a line. And I want to thank our TA Jonah for putting this into just super simple language like that. I really appreciated that. So that's why we do it. How? You guess. And that's really troubling to some of you. What do you mean, I guess? You say, well, what do you think the data is supposed to look like? What do I think it's supposed to be? And you make a guess. And that, again, is really unsettling, so let's walk through an example. So let's imagine that I had some experimental setup, that I had an object, and I released that object, and I somehow was able to measure the velocity of that object. Now, why am I not just doing what you all did? Because what happens is you're feeling overwhelmed, you're feeling uncertain about what to do. I walk you through the process, you copy that process, you learn little from that process. So instead, I'm doing an analogous problem, hoping that you will feel less overwhelmed after you see this, and then go through your data in a similar fashion. So we really are trying to get you to learn something. We don't want you to know the answer. We want you to know how to get the answer. So I have collected data here, right? So I have some heights, I have some speeds that I somehow measured, and I drop them. Well, the first thing I do, and this is my tennis ball, is I make a plot, right? So I've taken my height measurements here that are just from this table, and I plotted them against these speeds. And I have error bars on here, which I'm going to talk about. How the heck did I get those error bars at the end? All right. So I have some height and I have some speed and I plot it. And I ask myself, is this a nice, well-behaved curve? Is this a nice line? And I think you would agree that it's not a very good line. It's more curved, is kind of a better behavior. And so the question is, how do I transform this curve into something that looks like a nice line? All right. And so then we said, what do? You guess. Well, we're going to guess that whatever was happening in the system, that my acceleration was equal to gravity, or more importantly, that I had uniform constant acceleration. Why am I going to make that guess? Well, first to see if it's true, because if it's not, then the problem's harder. So I'm going to make that guess because that provides me three nice equations. So I go back and I say, okay, what did I have? I had height or position, and I had speed. Those are the things I had. So let me find an equation that relates those things together. Well, this equation has height, it has initial speed, but it doesn't have final speed. This equation has final speed, but there's no height. But the third equation, however, has final speed and a displacement or a change in position or height. So we're going to start with that one. So I'm going to say let my initial position be 0, wherever I let the ball go or whatever, we're going to call my 0. And so that then gives me, for equation 3, the following formula. And the point is, if this plot is generated using this formula, we can make it a line. What's the formula of a line? All of you know this. Y equals mx plus b, right? So what we do here is we just write the formula out next to what we think the right answer is. And we're going to do what we call pattern matching. That is, we're going to let this be our y variable. We're going to let this be our mx variable. How do I know this is mx and not this? Well, there's no variables in here, right? There's nothing changing. So this is my mx variable. And this is my constant added variable, or my b. So we're going to let y equal b squared. We're going to recognize that that shouldn't be changing. So we're going to let our m equal 2a. And then we're going to say our x term, so to speak, in this case is y. And our constant or intercept in this term is v naught squared. Oops, I just noticed a small error here. This should say y. So now what we're going to do is we're going to make a plot of y versus v squared. V squared versus y. So let's take a look at what that looks like. So I have now plotted, in this case, v squared versus my height. And if you look at this, this is a much nicer line, right? This looks quite linear. So this has a behavior that I can make sense of. And so now I can go back and tell you what is the slope. I can tell you what is the b term. And I can determine values like acceleration. I can determine values like initial speed from making a nice linearized plot. That's what we want you to do. If your initial plot is not linear, you're going to make a guess that turns it into a linear plot. Okay, if you have questions about that, please reach out to Professor Muhammad in her office hours on Sunday, reach out to Dr. Tabashnik in his office hours on Sunday, or on Monday, reach out to one of us as well. You can send messages on Teams or email. So how do I add error bars, right? So how to do error. I'm sorry I couldn't make an Excel video today, but I can tell you the steps. In Excel, you make your chart. You then select it. You go to the chart design menu. You add a chart element. The chart element you add is error bars. It'll say what kind of error bars. You say standard error. And then you select the error bar. So you're going to click the error bar on your graph, right? It's going to put some kind of error bars. You're going to pick it. When you've selected that error bar, you'll then format it. You'll go to a fixed value. You then set your values for X and Y. If you're not sure what to do, pause this video, open up Excel, and walk through these steps one by one by one. And then you're going to make sure that you select the fixed value. Don't just do standard error. Do not just leave it at standard error. You have to format your error bars, right? This is going to put these huge whopping error bars on there, and they're going to look quite similar to this. So we kind of know you didn't change them. So instead, you want to format them correctly. What does that mean? Well, how far off do you think your height was, right? Do you think that you measured the height of your ball at 1.0 meter exactly, and the person who was holding it let go of it exactly at 1.0 meter? So it's your job in this case to kind of look at a meter stick, think about how far could we have reasonably been off without anyone noticing, and then tell us that number. And that's going to give us your error bars for height. Then the question is, how far off was your time, right? Your X and Y error are not the same. So how far off do you think your time measurement was? That's for you to, tell us. You have to explain that in your write-up for us. And hopefully reaction time will help you understand that. If you didn't do something that required you to use a stopwatch in the standard way, you have to determine what your error was in that case. Do reach out to us. Do ask questions. Note that we don't want to grade your lab twice, so don't say, here's my lab, does everything look good? You need to be more selective. You need to look at the parts that you're not sure about, and you need to ask us, does this part look right? And then tell us why you're not certain about it. All right? It's hard to critically evaluate one's own work. It's hard to look at what you've done and figure out how to ask questions. But I'm going to ask you this question. When will it get easy to do that? And the answer is it doesn't get easy until you practice it, like everything else, right? Many of you, when we ask you questions, you say, oh my gosh, I haven't done that in years. Well, at what point do you say, it's time for me to just learn this? We hope that point is now. It doesn't mean it's easy, but we're hoping that you use this course as an opportunity to push yourself to learn the skills that you know you need to know. We're here to help you. We're here to support you in this journey. And please do reach out with questions and do challenge yourself to get stronger in your skills. Thank you.